Hello, in this video we are going to look at simplifying expressions by collecting like terms. Now a like term is a term within an expression that contains the same variable. So this could be an a b, an x squared. But in order to simplify, we do need to make sure those terms are like terms. That means they are the same. We can only add them if they are the same type of term. So we're going to have a look at some examples to show what we mean by this. So in the first example, you can see we've got k plus 3k. Now, both of these terms use the same variable, the same letter. So they're both using k. So this means they are like terms. So we can add these together. Now, it's worth noting that k is the same as 1k. So I'm actually adding 1k plus 3k. Now have a look at those numbers in front of the letters, the 1 plus the 3. That's the bit I'm going to add together. That's going to give me 4, and the k is going to stay the same. Think of it like 1 lot of k plus 3 lots of k is equal to 4 lots of k. In part B, it's very easy to get tripped up by a question like this. So all of our terms contain m's, and you're probably thinking, fantastic, I just add them all together. However, not all of these terms are like terms. So the 2m and the minus 1m, they are like terms because they both contain an m. However, the m squared is actually a different variable. So this is not a like term. We cannot add it to the other two. Now, we also need to watch out for negatives. So what I quite like to do is circle or square around my terms, and I include the sign that is in front of each of the terms. And you'll notice I'm using a different colour for my two different types of terms. So I've squared my m's in red and my m squareds in green. Now what I'm going to do is I'm going to work a colour at a time to simplify. So I'm going to start with my m's. So I've got my 2m and I've got a minus 1m. So my 2m subtract 1m actually leaves me with 1m. And we don't need to write the 1, although you can if you wanted to. And lastly, I've got that m squared. So like I said, we can't simplify it because it's not like. This is our final simplified answer. We've got an m term and an m squared. Now in part C, once again, we've got two different types of variables. We've got an x and a y. And you might think to yourself, well, hang on, what about that xy? Now, the xy is actually a completely different type of variable. It's a different term. So I'm going to circle that one separately because it is not the same as, for example, my x term. So even though it's got an x in, it's not the same because it's got the y as well. Now I've got two x terms in this expression. So I've got a minus 3x and a minus 2x. So I'm going to use green for those. And I'm going to lastly put my y in red. So in this example, I've actually got 3 different terms that I need to add, and I'm going to do this one at a time. So I'm going to start with my 6xy. Now there's only one xy term, so that's not going to change. Let's look at my x's next. Now this is where it's really easy to get the signs, the negatives, and the pluses mixed up. So we need to think of this as minus 3x minus another 2x. So minus 3 minus another 2 is minus 5. So this term is going to be minus 5x. Lastly, I've got my plus y on the end. So there was no other y terms, so I can't do anything with it. There is my final answer. Now part D, another one that's a little bit tricksy, and the reason it's a bit tricky is that it's got A's and B's, and it's got A's and B's in all 3 terms, but they all seem to be written slightly differently. Now the term 2ab contains the variable ab. And the term minus 5ba also contains the term ab, but it's actually been written in another way. So what you might like to do is rewrite the question with the a's and b's in the same order. Okay, so ba and ab are equivalent to each other. That means that they're the same. But when they're written in the same order, it makes it a little bit easier to spot that they are the same and these terms are like terms. So I'm going to circle those in green, and I'm going to have my a squared b as my second different type of term. So this has got an a squared in it, so it's not the same as having ab because it's a squared b. So now we can simplify. So let's start with my ABs. So I've got 2AB minus 5AB. So the ABs are going to stay the same, and it's the 2 and the minus 5 that we are looking at. Now 2 minus 5 is minus 3. So that's going to be a negative term, minus 3AB. And then the minus a squared b, there's nothing I can add to that, it's all on its own, so that I'm just going to pop at the end. And you can see, watching out for signs, so the a squared b was negative, it had that minus in front of it, so in my answer it's got the minus there as well. Okay, last couple here. Again, very easy to get muddled with ones like this. So in part E, I've got actually two different looking A's, and you might think, well, they are both A's. However, the capital A and the lowercase a are different A's. They stand for different variables. So I'm going to use different colours to highlight those two because they are not like terms. And then I've got my numbers. So I've got a +3 and a -1. So these are like terms. So if you've just got numerical terms, they are like to each other, so they can be simplified. So now I'm going to work my way along my expression. So my 4a, that was the only term with the lowercase a, so there's nothing I can simplify. My 2 with my capital A, again, there was only one term with a capital A in, so that can't be simplified. But my numbers, I've got 2 of those, so I am going to simplify these. So I've got a +3 minus 1 is actually equal to a +2. So when you're worried about what sign to write, think about the sign of the answer. +3 minus 1 gives us a positive answer, so it's going to be a +2 on the end. Last one at the bottom here. So I've got P's and Q's in this example. So my first term is a PQ, and I've got another PQ term sat in the middle here. So both of those are PQs. And I've got some Q terms as well. So I've got a -3Q and a +3Q. So let's work our way along once again. So looking at my PQ terms, the ones in green, I've got 4 PQ plus 1 lot of PQ. Now remember, the PQs are not changing. I'm just adding the numerical part called the coefficient. So that gives me 5 PQ. And then I'm going to have a look at my Q terms. So I've highlighted these in red. So -3Q plus 3Q is actually equal to 0Q. Now I don't need to write 0Q. I can just leave that because the term is 0. We don't need to write it down.